Okay, so here we are. We're going to be solving quadratic equation 6.2. In here we talk about to solve quadratic equations, you can solve by factoring, solve by using a quadratic formula, and solve by completing the square. Later on we're going to look at completing the square, but right now we're going to focus on solve by factoring. In the previous unit we did a lot of factoring. Now what we're going to be looking at is how we can use solve by factoring to be able to solve quadratic equations. So let's start. Now, since we're looking at being able to focus on factoring, we're going to focus on how we used to do that. To solve by factoring, you have to factor the equation, set it equal to 0, and then we're going to take each factor, set each factor equal to 0, and solve for the variable. And now this will find the roots, zeros, x-intercepts, and solutions to the equation. So the roots, zeros, x-intercepts, and the solutions to the equation. Let's look at examples to be able to solve by factoring. So here are some examples. And with all these examples, you're going to notice that some of them are not in the form that we want it in. The first one, though, is in factored form already. So we've already got it factored, so it makes no sense to expand and then factor again because it's already been done for us. So now the next step is to solve for r. So we take r minus 3 is equal to 0, r plus 2 is equal to 0. So you set each of the factors equal to 0. Because the idea is here, there's a product that makes the answer 0. The only way that can happen is if one or the other bracket is equal to 0. Because 0 times anything is 0. And there is no other way to get 0. So the idea is one of these must have a value of 0 in order to make the whole product 0. So either r minus 3 is equal to 0 or r plus 2 is equal to 0. So we solve for r, and the first one we get r is equal to 3. And the second one we get r is equal to negative 2. So therefore, r is equal to either negative 2 or 3. And what's going to be important here, folks, is that you put them in order from least to greatest. From left to right, if you think on the x-axis. All right, the next one, part B. Set each factor equal to 0, just like that. Once you set each factor to 0, you solve for x. So the first one, you're going to move the x is equal to negative 3, divide both sides by 4, and you get x equals negative 3 over 4. Same with the second one, and we get therefore x is equal to negative 3 over 4 and 2 over 5. Notice with this one, 5x is equal to 2, and we divide both sides by 5, so that's how we get 2 over 5. So negative 3 over 4 and 2 over 5. All right, next one. This one is not in factored form, so we have to factor this, starting with the most common or simple type of factoring, and that is common factoring. We always common factor first if we can. In this case, we can, and we're lucky, and we get x times x minus 1 is equal to 0. And I just want to go back for a second. Notice that it's x times x minus 1. Treat that x like it has brackets. So originally it didn't have any brackets. It looked like that. But when we're trying to set it equal to 0, what possible values could it be? Well, this could potentially be 0, or this bracket could be 0. So it's like treating that x like it has its own brackets inside there. So when we try to find the factors, the roots, we set x, the red bracket, equal to 0, and the other bracket equal to 0. So we find out that x is equal to 0 or 1. All right, the last one. Again, we have to factor. What two numbers multiply to give you 14 and add to give you negative 9? That will be, let's see, we're going to get the values of negative 7 and negative 2. Now here is what you have to understand about factoring. The idea is that we need to find out how to get the factors here. And we do this by, let's look. We want a negative 7. To get negative 7 means that I need to have a negative 7 here. To get the 7, I need a negative 7 and a 1 here, but also a 1 here. So when I do a OI, the outside, I get negative 7, and then here will be a 2, and here will be a negative 1, and that will give me my negative 2. Let's just watch that again. So we both have to be negative because the product is positive and the sum is negative. That means both are negative. And then we have, oops, that's a little bit too much for you there, folks. So let's just go a little bit back. So what we have here, negative 7, negative 2. And we have negative 7, negative 1, 1, and 2. So let's focus on this. So we need 2 negatives, so we need a positive 7. One has to be a negative 7, the other one has to be negative 1 to give us positive 7. Now, I also need a negative 2. So right here, my outside is negative 7, so we're good. My inside is negative 2. Well, that 2 comes from the 2x squared over here. So x times 2x is 2x squared. X times negative 7 plus negative 1 times 2x, that gives us negative 9x. And finally, our last is negative 7 times negative 1, which is positive 7. So we find the roots. X minus 1 is equal to 0. 2x minus 7 is equal to 0. We get x equals 1 and x equals 7 over 2. Therefore, okay, these are the values that x could possibly be. All right, let's look at another problem. Here's a word problem. A ball is thrown straight down from a 180-meter cliff. The relation h equals negative 5t squared minus 5t plus 180 is a model that gives the approximate height of the ball h in meters at t seconds after it is thrown. How long does it take for the ball to reach a ledge 80 meters from the base of the cliff? Well, for that to be the case, we need to be able to visualize what's happening here. Okay, so this is a ball being thrown, and we want to know when it reaches the 80-meter ledge right here. So to do that, we need to let h equal 80. When we do that, that means the height is forced to be 80. We set it equal to the equation. And folks, whenever we want to factor or solve an equation, we have to make sure one side is 0. Right now, neither side is 0. So we have to take this 80 and move them over here so that we have 0 is equal to negative 5t squared minus 5t plus 100. That's 180 minus 80 is plus 100. The next step we have to do is remove this negative 5 away from the whole equation. So we're going to divide out negative 5 out of the whole equation, because to factor, we always should common factor first. So I'm going to common factor the negative 5. I'm left with a simple trinomial. And what two numbers multiply to give us negative 20 and add to give us 1? And that would be t plus 5 and t minus 4. What does that mean our t values are? Let's see. One of the t values is negative 5. The other t value is 4. I want you to look at these numbers. Look at the question. The question t represents time, t seconds. Which one of these answers does not make sense? Well, that, of course, is t equals negative 5. It's impossible to go backwards in time. So therefore, we have our answer, t equals 4. So therefore, the ball reaches 80 meters at 4 seconds. And we're done the question. All right, moving forwards. Example 3. A photograph measuring 12 centimeters by 8 centimeters is to be surrounded by a border before framing. The width of the border is to be the same on all sides. The area of the border is to be equal to the area of the photograph. Find the width of the border. So what we're having here is we have a photograph. That photograph measures 12 on one side and 8 on the other. Now, knowing this, that it's 12 and 8, we're going to have a border to go all the way around this picture frame. This border, okay, is, it goes around the picture frame and it has a specific area. Now, this border is X width across, so therefore the entire border, including the picture, will be a total of, on one side, 8 plus 2x, and then the other side is 12 plus 2x. Why is that? If you look here, this side is 8. You're adding x on this side and x on the other. So we're adding 8 plus 2x to get across the one side and 12 plus 2x to go this way, right here. All right, knowing this, we let x represent the border width, so it's a uniform width all the way across, which is why we can use the x. And we find out that the area of the border, or of the whole thing, is double the area of the picture. That's what this information is about. So, double the picture. All right, let's just hold on. Okay, so what we have here is double the area of the picture is 192. Why we doubled the area is because the area of the border, it says right here, the area of the border, whoops, sorry about that. The area of the border is to be equal to the area of the photograph. So if we double the area of the photograph, we get 192. 192 is the total area of the whole box on the outside, the whole area including the inside of the picture. So 12 plus 2x is the area, is this side, times 8 plus 2x is this side, so length times width covers everything inside here. And that has to be double the picture. What we do now is expand this expression and move the 192 over so that we have, that's right, a 0 on one side of the equation. And we do this, and we move everything over, collect like terms, and this is what we get, folks. And what we can do here is common factor of 4 out, just as such. And then what two numbers multiply to give us negative 24 and add to give us 10? That would be positive 12 and negative 2. Now, when I x plus 12 and x minus 2 to find the zeros, I know that if I plug in a negative 12 in this bracket, I'm going to get 0. So negative 12 is the x. And if I plug in 2 for x here, I get 0 as well. So there's our two numbers. Now looking at the question, what is x? Well, looking at the top, x is the border width. It is impossible to have negative 12 as a width because you literally are going into the picture to do that, and that makes no sense. So negative 12 doesn't work, so we write our therefore statement that the width of the border must be 2 centimeters wide in order to satisfy the information here. All right, folks, that's it for the factoring. Work through it again and work through the problems. Don't forget, though, that if you have a word problem that has no equation given to you, that will be your inquiry question. All right, take care. Have a numerical day. Bye.